In practice final answer key. So I'm going to run through all the formulas for the whole semester. If you've used all your formula sheets and not lost any points on your formula sheets, Ash, then you could bring all your formula sheets in with you for the day of the final. You don't have to fit them all in a 5x8 card or whatever silly thing, right? You can bring in scrolls of formula sheets as long as you don't bother other people. Okay. So this is kind of hopefully spur your memory about questions to ask as we go through these formulas. Now, if you recall, Chapter 1 was all definitions, right? An exciting way to start the semester off. That was great. Chapter 2 is where we got into histogram stuff. So you have to remember how to do your own class width, all that kind of business. The first real formula we hit is a formula we don't really use anymore. I'm not going to make you do the variance and the standard deviation. Remember the sum of x minus mu squared over n or over n minus 1 if it was a sample. All right, so the real first formulas we hit were like, I don't know, if you really want to write this down for yourself, there's the mean, right? Standard deviation, I'm not going to make you calculate. Then we hit probability stuff. We get z-scores at the end of Chapter 2. That formula you should know by now. And we get into Chapter 3, of course, with all the probability stuff. Yeah. Okay. So I'm thinking, if I'm you, most of you would just bring in all your formula sheets with you. You might want to start fresh if you've lost some points in some of those. Then we get into the distributions, the probability distributions. So we started off with just the regular general probability where I give you x and p of x. Remember those days? Table of x, table of p of x. So this would be stuff like this. And then we move right into binomials in the same chapter. So I got this kind of thing here. Good. So every time we talked about a distribution, I have to figure out how to get its center and its spread. So we got a center and spread. We got a center and spread. Every time we learn a new distribution. Then we get into normal distribution proper. And the real first new thing is this guy here. If I were you, I wouldn't even write this thing down. It's the same formula as this. You just use the right standard deviation. So if I have a group of people or things, I want to use this standard deviation. It's the same formula. You just use the correct standard deviation for the moment. But you can write it down if you want to. All right, so that's chapter 6, as I remember, and then maybe it's chapter 7. Yeah, it's chapter 7. Chapter 8, we get into confidence interval stuff. Oh my God. Aren't you happy? I'll let you write all these down. And you're like, not much. Okay. Can I erase this part? Everybody's got these, right? Nobody's back here in the green. Okay. So that's confidence intervals, and then we get into hypothesis testing. And the only real new formula with hypothesis testing was this guy. Note P and Q have no hats in there. And if you did the extra credit, you could write this down here. If you didn't do it, why the hell would you write this? But I'm going to have an extra credit on the final related to this one, just in case you did it. And then we get into the linear correlation stuff. It's all in the calculator. You have to interpret what you see. But you got to know the calculator procedures for getting a line of best fit and the R and all that kind of business. And then we get into chi-square. And really the only one you have to worry about is this guy. And, you know, I think I made, I can't remember if I made that extra credit or not. Did I say that was extra credit? The 11.6? Yeah. So if you want to, you can put this down. Okay. And that is the semester as far as I can remember. Anything I missed maybe? Any suggestions on other things to put down? Now's the time to give me suggestions so I can shoot it down. Or maybe not. Okay. Sorry.
What about like x equals mean?
Oh, sweet. Not the plus or minus one. You got to know that one, but. Yeah, this backwards thing for z-scores. Sure. Remember, use that if I ask you to find a time that's in the 11th percentile. You have to look up the z-score and then convert it back to a raw score. So that's the backwards. It's just the z-score solved for x. That's where weak algebra skills definitely hurt you. Not understanding how to solve an equation for a different variable. Anything else? So I totally agree with that one. Like a G on there. So if I did forget something and it was on an earlier formula sheet, obviously that's fine. Anything else should not be on your formula sheets. Okay. I have a few extra. Anybody need a practice final still? Anybody else that came in later? Everybody's got a practice final. Okay. I still have a part 2 of the answer key to go get. So if you want that, you might want to stay. So today's wide open. We could do anything that you want to do. You could do any problems, you could do any examples. Maybe I should have just brought the final exam and gotten it over with. No.
Can we do question 2?
Oh, all right. So we have 3, 4, 8 on green pieces of paper. Everybody's got. So we got everything up here. We already
The
double.
last one.
Oh. So we got, what was it? 3, 4, 8. Ooh, yeah. And 2, 5, 9. And ask what's the probability. So I pick one piece of paper. Let's probably get a red piece of paper. That's easy enough, right?
Mm-hmm.
What would that be?
Yes.
Yeah, there's 3 red out of 6 total. So it's always the number that match what I'm looking for. That's the number of chances I have to get what I'm looking for out of the total number of things that could happen. So there's 3 out of 6 things that match what I'm looking for. This is part 1, by the way. Probability of odd. Every time I do a probability question, the A, B, C, they're separate. They don't build. So not still talking about red paper. I'm just probability to get an odd number out of all those. 3 out of 6 again. So half of them are odd. Green and even. Yeah, the bottom's still going to be 6, right? To begin with, at least. Because I haven't given you any information. Yeah, and how many are green and even? 2.
No.
I like it. And then even given green. Yeah, there. So given that it's green, so of course what's the bottom going to be now? 3. Out of those, how many are even? Well, we kind of already know. 2. So 2 have a chance. Kind of makes sense. Given that it's a green piece of paper, it's a higher probability than an even number because there's more even greens. So if I know it's green, it's a higher chance it's even. Okay, I like it. I like it. So for example, real quick, after the election, how do they call the election before the votes have all been counted? And they've gotten in trouble for it. In fact, they got in trouble for it this last election. They called it too early. So how do they do that? Because they know where the votes haven't been counted yet. Given that it's in that area, what's the probability that more votes would go to this person? Well, they know the historic voting patterns, so that's built into how they predict. What's beautiful about probability and statistics is always a chance that you're wrong. And the news stations, in their effort to be the first to say something, they often have to go, oh shit, we were wrong, sorry. So I don't know if anybody's paid any attention. There's been several races that have actually gone the other way. No? Of course we have 2000, the year 2000, when some of you guys were born. Right? They were counting chads as you were born, maybe. You guys know, not chads like Chad, but hanging chads. You guys know anything about that? No? You should look it up. Look up the election of 2000 and the entire United States waiting through December until the Supreme Court could tell us who the hell the president was going to be. Woohoo! It was a great time. And they had a picture of people looking, is that did somebody poke through this? I don't know. Anyway. Sorry. Now part 2 of this problem deals with picking 2 things without replacement. So what happens if I pick something and I don't replace it? Things are going to change. Red then green. So it's probably the first one's red. 3 out of 6. And then I throw that away. So what changes exactly? There's still how many green? Good. So that's 1/10, I think. 3/10.
Yeah.
Yeah, 30%. Okay. Okay. And then part B, 2 odds. Probably odd, then odd. Probably get an odd 3 out of 6. And then, and means multiply. That's why I'm multiplying. Another odd, so what's that second? Yeah, 1 less odd, 1 less thing. And that'll be 2/10. 20%. Is that cool? So when I pick 2 things, you're gonna be multiplying. And then how the other one changes is based on if it's with or without replacement. Is it the thing I lost or not? See, this one didn't change because I didn't lose a green. I lost a red. Yeah. Oh, which one? I was trying to catch. Which one? Oh, yeah. This goes to 20%. I reduced it all the way to 1/5. Yeah. Math goes, I don't give a shit. 1/5 is 2/10. It depends on if I ask for it. To be honest, if I don't ask you to round decimals to whatever place, you can leave it as 3/10, right? Oh. Because some of you guys lose points because you can't round correctly. So if I don't ask for that, don't even go there. Of course, just learn how to round correctly. I don't know, that's even a better option. You're not like, I don't need to do that after this is my last math class. I never need to do that again. Oh, shit. I'm not going to shop at your store if you open something. Round everything the wrong way, I pay more for you. No. I'm not going to do that. I have a feeling not everybody got their stuff back. Anybody not get their stuff back?
Can I get an answer?
Yes. What's your name again?
Sorry.
Okay. And you get it perfect. Yeah. Sure. That's not the whole answer key yet. Oh, everybody's got this by now? Probability x greater than 3. On this problem, there are 2 ways to do it. What does x greater than 3 mean? 4, 5, 6. So then how do you calculate? You just add all those up. Or you could do 1 minus the probability x is 3. Now why does that work here? Because what's the only thing this leaves out? 3. If I said x greater than 4, can you do 1 minus the probability x is 4? No, because that's not the only thing that leaves out. So some people, if I said probability x greater than 5, if you say this, that doesn't make a damn bit of sense. You do not understand the idea. If you do 1 minus this, you found the probability x is not 5. You didn't find the probability x is greater than 5. How would you do this if I said probably x greater than 5? What would you do? What is greater than 5 in this problem? 6 and 7. So I just add those probabilities up. 1 minus 5 doesn't make a damn bit of sense. So the idea is, if I have a question that has more work involved, I could do 1 minus the opposite of that question. 1 minus what it leaves out. Because all the probabilities add to 1. Let that make sense. I'm not saying whatever number you see there, just do 1 minus it. That doesn't make any sense. That's not the idea. that cool? No? Not at all? You asked it, right?
How do you get the 0.9 out of that?
All right, what's probably x is 3?
0.11.
Yeah. 0.11. What's 1 minus 0.11?
Okay.
Yeah.
Part D, so might the data be normal and why? That's just because usually within one standard deviation, you should want.
Yeah.
Okay.
Yep. So it might be like really roughly normal, but it's not going to be normal because it's not the corrected percentage of data. Christina, you got a...
I'm on that same question.
Because we all know that within one standard deviation, what should a normal distribution have? 68% of the data. Within two, 95%. So this had 75% within one step.
So is that different than when we find like, so like, you know how like on the one question, I can't remember what chapter, it's like, would you consider this normal? And it was 2 standard deviations.
Ah, okay, sure. And then there should have been
Is that the
95%. So if it's a normal distribution, if it truly is normal, then within one step there should be 68. Within 2 steps it should be 95. So if I'm close to that, maybe it's normal. If I'm like 7% over, then it doesn't seem like it's going to be really normal. So that's the kind of question that would make it really obvious. Sort of like our R value is going to either be strong or weak. I would make this either holy shit, no way, or oh yeah, it's just that's like 69 instead of 68%. It could be normal. I would make it really obvious. Oh, yes. Because we're testing the claim that we expect it to follow that pattern. So the expected will be the part that you calculate. The observed is just going to be copying down numbers. Because somebody's going like, I see this, I just got to copy it down. Expected is theoretical. You have to actually calculate it. So if I said, I expect it to be uniform, you remember how to do that. Then you take the total amount divided by how many categories, because they're each going to get the same amount. Or the only other way I could do it is to give you a percentage that should fall in. And then, well, it'd be 13% of 342, right? And then 20% of 342. Yeah. That's how many I would expect if it follows that pattern. And the whole idea that goodness of fit test is it could follow the pattern, but it doesn't have to follow it perfectly. This is just a sample. That's why it's got to be so different. We look at that critical chi-square. It's got to be more different than that to be like, no, this doesn't look like it's following the pattern. But it could have little variations, right? So that example in the practice final, you should come out not finding evidence that it's different. Because the differences aren't that big. Yeah.
So, if you're valid, I mean, when you ask for the valid probability distribution,
Yes.
and you do get like 1.0001,
Yes.
you just say that not a valid.
No. Yeah, well, not invalid, totally. It's completely valid. What's the sum of the probability supposed to be? 1. Is 1.0001 really that different from that? No. So you have to tell me it's supposed to be 1, but 1.0001 is fine. It's probably just a rounding thing. So don't say it's valid because the sum of the probability x is 0.9999. Then I'm like, do you really think it's supposed to be that? Say it's 0.9999, which is approximately 1. So that captures the idea that it's supposed to be 1, but that's close enough, holy shit. If you get 0.97, no, they left something out. That's way too far away from 1. Yeah.
On 4A, you have the probability 35, choose whatever, and then you have or binomial PDF. Is it okay if we write that on the test?
No. Yeah, that should have been like a check. You could check it using binomial PDF. Yeah. Also, before I forget, on 4B, number 2, it's different on the answer key because there's something we used to teach. So let me do 4B part 2 on the board since it's different on the answer key. Somebody was like, yeah, I was about to get you on that, Jeff. All right. So 4B2 on the answer key is a different question that you do not have to worry about. We did not talk about the NAB. The NAB is the normal approximation to the binomial distribution. We didn't talk about it, thank God. It takes a long time just to say it. 4B2 just says find the min and max expected values. How do you find those? Yes, within, or 2 standard deviations. So the min would be mu minus 2 sigma, mu plus 2 sigma is the max, and then you just plug stuff in, right? So for the mean, it was, where are you at? There it is, 46.08 minus 2, 6.476. Are you guys with me? You go down 2 steps, up 2 steps. Why was, let me try to put this in context of what we know now with hypothesis testing. Hypothesis tests aren't always 2, -2 for the rejection region, right? They change. This is what we consider to be unusual outside of here because what percentage is within 2 steps for normal distribution? What percentage is 95? So what percent's outside of that?
5.
And 5% has been the generally accepted percentage that means unusual. If something has a less than 5% chance of happening, it's generally considered to officially be unusual. So there's a 6% chance it's officially not unusual that it would happen. Right? We just had to put a bar somewhere. Hypothesis tests go, wait a minute, that's crazy. I need to be able to move that bar based on if I'm sitting in a nuclear power plant, like I keep talking about, right? I need to be able to move that bar. So that's what the alpha does. It moves that bar. But before we got to hypothesis tests, we just said, we think 5% is good enough, so let's go up and down 2 steps. So now you just got to plug this in a little calculator. Whatever the hell this shit is. All right. You guys with me? Let's do it. Somebody do this for me.
33.1.
What is it? Sorry?
33.1.
33.128? Good Lord. There you go. So this would be 49 point? 59 point. Who? 032. So double check that. The min expected, the max expected. So would it be weird to see 27?
Yes.
Yes, because it's outside the realm of what's considered usual. So that's evidence, not proof, never proof, but it's evidence that something is kind of weird about wherever you are. Right? So if I get off a plane in a country and every person I see is over 7 foot tall, I'm like, okay, what country am I in again? What is happening? Something weird about where I am. Is that a traveling group of people, of performers? Is that, you guys with me? A little bit? That's a big thrust of this topic, is how to test whether something is different than what's normal. That kind of tells us, has something changed? So based on what's happened before, we expect this. And then this happens. Holy shit, is that evidence that things have changed? That's a huge part of this course. And that's the kind of thing we see all the time in the news. The economy's getting better. How do they know? They found enough evidence that it's getting better. Right? Then you can argue, is it getting better for everybody? Stock market going up doesn't mean shit to me, necessarily. Okay. Let me go run. I'm going to go get the other page of the key. Give you guys a minute to think about questions. I'll be right back.